Welcome everyone, and so we will start our new chapter today, trigonometry. Now, I don't know how many of you are actually interested in studying trigonometry because it is what trigonometry reminds us, is many formulas. Sine square theta plus cos square theta is equal to 1, cos to theta is equal to cos square theta minus sine square theta, and so many formulas come to our mind. Sine 3 theta is equal to 3 sine theta minus 4 sine cube theta, and so such many formulas can come into our mind, and we think about it as a very boring subject, trigonometry. We have to keep drawing triangles after triangles after triangles. I can understand what you feel, but what I'm trying to do is in today's lectures will be basically an introduction to the topic, and I would like to introduce this topic in a different perspective, as much as it is possible. Uh, So yeah, try to understand carefully what is happening, and yeah, as always, if you have any doubt, just let me know. Okay, so let us start. So let's start with the definition of the word trigonometry. See, trigonon means triangle, metron means measure. So this is the word, these are the words from which trigonometry, the word trigonometry comes from, and therefore we can easily understand that trigonometry is the maths associated with triangles. Now, these are Greek words, okay? Trigonon and metron is a Greek words in the Greek language, and so now usually we have associated this with triangles, and we learned it with triangles. In the lower class also you learned it with triangles. You learned it as, I don't know whether you, basically right triangles, and these are the things that we learned. In trigonometry we learned about 6 types of ratios: sine, cosine, tangent, cosecant, secant, cotangent. Sounds like Hebrew, I know, but it's not actually Hebrew, it is Greek. Okay, so anyways, and we also learned about short forms: sine, cos, tan, cosec, sec, cot, all these things. Now, these are the short forms of these things. We usually use the short forms in solving questions. Now, and I don't know whether you studied this short form, Sokatowa. I know it sounds weird, sounds like a Japanese name, but it is not. I mean, I don't know whether there is a Japanese name like that, but as of my knowledge, this Sokotowa is just an acronym. Acronym for what, you may ask? Yes, I would like to say that it is just to show that sine is opposite by hypotenuse, and cos is adjacent by hypotenuse, tan is opposite side by adjacent side. Just remember that there's a short form, Sokotowa. Now you have studied that also, so I don't have to teach you that. Now, for a long time we associated trigonometry with triangles. Even the name itself says it is triangles. It's a measure of triangles. But let us try to look on it with a different perspective. That is, I am going to draw my x-axis and my y-axis, and I'm going to draw a circle now. I'm going to draw a circle of radius 1. That means this is a unit circle. Unit circle means it has unit radius. Unit radius means the value of the radius is 1. That is why it's called unit. Unit means 1. So unit, usually we say unit means it refers to 1 usually. So this is a unit circle. Unit circle means, I repeat, unit circle means the radius of the circle is 1. Okay. Now why did I draw a circle? Yeah, we'll come to that. We'll come to that. But we let's go back. I know. I just wanted to show you the circle. Now let's go back to the triangle. We know all these short forms. Sokotova, sine is opposite by hypotenuse, cos is adjacent by hypotenuse, tan is opposite by adjacent, and all. Now, suppose the hypotenuse value is 1. What will be the value of sine? Okay, this is my theta. And what will be the value of sine? Sine we know is opposite by hypotenuse. Now the hypotenuse value is 1. That means sine theta will be O by 1. That is O. That means just the opposite side. Sine theta will just be the opposite side. Okay, let that be there. Now let us go back to a unit circle. Now we know that all the radius everywhere is 1. So I'm going to draw a line like this. This is a radius, and as it's a unit circle, this value of this radius is 1. Then I'm going to draw up a line like this, and then I'm going to connect both lines. Now I have a right triangle with angle 90 and theta. Now, as we all know, sine theta is equal to O by 1. Why? Because the hypotenuse is, this is the hypotenuse, and we know the hypotenuse is 1 because its radius is 1. So sine theta is equal to just the opposite side. And what is the opposite side? This side, the vertical length. So sine theta is actually the vertical length. That means the vertical. And what is cos theta? Cos theta is adjacent by hypotenuse. Hypotenuse is 1. So cos theta is actually just adjacent side. That means cos theta is this horizontal part. So what did we come to see? We came to see that sine theta is actually the vertical part and cos theta is actually the adjacent part. Or the cos theta is actually just the horizontal part. Now, I know this might be a little bit confusing in the beginning, but I want to show you something that is really interesting. At least it is very interesting to me. Okay. Now, what do we see? We saw this triangle. This was a triangle. We saw that inside the circle. Now, in this triangle, we saw that the length of the hypotenuse is 1, and the length of this side is sine theta, and then we saw that the length of this side is cos theta. Guys, look at this. Till now we all learned sine, cos, tan, everything as a ratio. Opposite by hypotenuse, adjacent by hypotenuse, adjacent by opposite side. This is all what we learned. But now I'm telling you, sine theta is just the length of a triangle with hypotenuse 1. Cos theta is a length of, it's just a length. It's just a length of one side of a triangle with hypotenuse 1. So what we studied as ratios has actually become sides. Now we all have learned about Pythagoras theorem. Right, all of you know Pythagoras theorem. What does Pythagoras theorem say? In a right triangle, the sum of the squares of two sides is equal to the square of the hypotenuse. That means the sum of the square of this side plus the square of this side is equal to the square of this side, hypotenuse. That is what Pythagoras theorem says for any right triangle. Let us apply Pythagoras theorem here. When we apply Pythagoras theorem here, what does it say? Sin square theta plus cos square theta is equal to 1. Now, does anything come up in your mind? Think. Sin square theta plus cos square theta is equal to 1. This is one identity that you studied in lower classes. Did you even know that this was just the application of Pythagoras theorem? So by just using simple Pythagoras theorem, this was a beautiful formula to which you arrive. Sin square theta plus cos square theta is equal to 1. Now it doesn't end there. Look at this. Last chapter in relations and functions, I told you that y square plus x square is equal to 1. This function I told you is the equation of a circle. If you check the previous videos, you will see I told you that y square plus x square is equal to 1. This is the equation of a circle. I mean, in that video I told x square plus y square, both are same. X square plus y square plus x square, both are same. So y square plus x square is equal to 1. Now compare both these two equations. Look at this. Both are having the exact same format. See? That what does it mean? That means sine square theta plus cos square theta is equal to 1 is also the equation of a circle. And that is the reason why. My friends, we are getting a circle. We are getting a unit circle. See, x square y square plus x square is equal to 1 is the equation of a unit circle, okay? That 1 means it is a radius, and 1 is showing the radius. Likewise, sine square theta plus cos square theta is equal to 1 is also showing the same equation, which leads to a unit circle. See, this is a beautiful equation, you know. Why is it so beautiful? Because sine cos is actually something that is related to right triangles. But we have come to know that there is the same thing that is, you know, that is having a relationship with the right triangles, you know, that can create a circle. Guys, think, what is the relationship between a triangle and a circle? Does it look does it look anywhere equal, or does anywhere similar? No. But still, these trigonometric ratios can bring together both right triangles and circles. Both triangles and circles. That is where the beauty of trigonometry lies, my friends. Now, let us look at few other things. I am taking you now. I'll be taking you to another site. That is this one. Now, I want to show you something here. That is, this is a unit circle that we saw. Okay. Now, when I change the angle, you know, the vertical line changes, the horizontal line changes, and the vertical line, you know, the vertical line shows the sine value, and the horizontal line shows the cos value. If you look at here, you know, the cos value they are showing 0.71. See, it is between just around 0.71. See, sine value they are showing 0.7. Oh, almost equal. You know why they are equal? Because it's sine 45. Okay, that because angle is 45. That I will tell you later. We'll come in the coming lectures. You might not be able to understand that now. Okay, so okay, let me put a different value. See, or see, this is almost 0.5. Horizontal length is 0.5. Therefore, cos 60.29, angle 60.29 is 0.5, and the vertical length, this is almost 0.87. See, now what is it? What are these things? 0.87, 0.5. These are actually, you know, the x coordinate and the y coordinate. What is x coordinate? X coordinate is the horizontal distance from the origin, and that is 0.5. What is the y coordinate? 0.87, vertical distance from the origin. This part, and that is 0.87. Guys, do you understand this great, you know, thing? That is, each point in a circle, what we are actually seeing, you know, is that every point in the circle, see, every point in the circles has two coordinates, x coordinate, y coordinate, and those are actually sine theta, cos theta. That means when you draw a graph, you already have experience of drawing graphs, and you know what is x coordinate, y coordinate. So now what you learned as some ratios, some time back, are actually the x coordinate and y coordinate of a circle, of a unit circle. Okay, now let me show you. We all know sine 0 is 0 and cos 0 is 1. Let us check that. Sine 0 means sine 0 means theta is 0. The sine 0 means theta, sine of theta is 0. So let's the angle becomes 0. Let us make the angle 0. Now the angle is 0. The horizontal length is 1. The radius, whole radius. So therefore cos 0 is 1. What is the sine value? Vertical length. There is no vertical line here. So therefore vertical length is 0. See? It is 0. So this is one proof. And also suppose we know sine 90 is equal to 0 and cos 90 is equal to 1. Sine 90 we know is equal to 1 and cos 90 we know it is equal to 0. Let us check that. Let us go to 90 and I'm almost at 90. Yes, see, the vertical length is equal to 1 because it's the radius, and the horizontal length, oh wait, there is no horizontal length, that means it is 0. Now guys, another importance of using this circle to understand trigonometry is, see, when we draw a triangle, we cannot go for all angles, because maximum angle we can go is just below 180. Then only we have two sides, and then we can join a third side. We can join a third side like this. I mean, sorry, not like this, but like this. You understand my point. So when we draw a triangle, we can only draw maximum to just some angle just below 180 degree. That is the maximum we can go while drawing a triangle. But if you are studying trigonometry with the concept of a triangle, with the concept of a circle, we can go to any angle which you want. Look, 190, 200, 220, 230, 270, 280, 290, 320, 360. We come back to the same, and then again we can go 340, 350, 360, and we can come back 720 degree. We can come back 1000 and something degree, and we can keep going like that. We can keep going. This is the beauty of learning trigonometry in circles. Okay, now let me show you something else. Look at this, my friends. Look at this. Here I'm going to show you the plot of sine. I'll show you the graph of sine theta, how it actually varies. Okay, look at this. This is my theta is equal to 0. That means angle is 0. Now sine value is increasing. I know I'm going a little slow here. That is for you guys to understand and to really grasp what is actually happening in trigonometry. So this is the graph for sine theta. See, if we look carefully, the vertical line is approaching more and more to 1. That means theta is approaching more and more to 90 degree. And as theta approaches more and more to 90 degree, we reach 1. See, we reach the point 1. Theta is 90 degree, and here also we reach the point 1. Now let us keep going. Let us keep going, and we see that the theta value increases and increases and increases, and now the theta is approaching 180 degree. And as theta approaches 180 degree, we understand that this vertical line is decreasing and decreasing, and as the vertical line decreases, the sine value also decreases. You can look at the graph, sine graph also, you see that it is going down and down and down and down, and it reaches 180 degree. Now let us keep going. Sine 180 is 0, and we keep going. Now we are sine's value is increasing and increasing and increasing, but in the negative direction. It is increasing in the negative quadrant, negative direction. As it increases in negative direction, it is approaching the value of theta is approaching 270 degree. Look at the value of theta. It is approaching 270 degree, and what value is it? -1. The radius is 1, but it is in the negative quadrant. It is a negative value of 1. Now let us come back to our starting point, and we see that the angle is, we are approaching 360 degree now, and as we approach 360 degree, we understand that we come back to the original value 0. That means because the vertical line is decreasing and decreasing and decreasing, and we come back to 0. Now, the beauty of circles, as I was telling, is, we are not limited to any angle. We can go to any. So, see, I can keep going. Look at theta. Look at this value of theta. I can keep going to 7. That means this is the second round which I'm taking. Already first round I'm taking. This is the second round, I'm taking. The value of theta is increasing. That means the angle is 380 degree. The angle is 390 degree. What happens now? I'm just going a little more fast, otherwise you will sleep. So see, 480 degree, 500 degree, 585 degree, 620 degree, 700 degree, 720 degree. 720 degree means we have to come back here again. 360 plus 360 is 720. So 720 degrees, we have to come back here. See the shape of the graph? I can make it more clearer. Because I went a little fast, the graph also appears, they're taking rough estimates. Okay, so you see that the shape remains the same. So it keeps going on, if I take a third round again around the circle, this graph appears once more. So it keeps going. Now, let us look for cos. Let me put this theta value at 0, and let us study cos. Let us see what happens when cos comes. Okay, now guys, look carefully. Okay, the sine value of end. 1 minute, let me just put the sine value first. Okay, this was the sine. Now when I put cos, this is what happens. Look carefully. The cos 0 is 1, so it starts from 1. See, the graph starts from 1 and it keeps going. The horizontal line is decreasing. In the circle, the horizontal line is decreasing, so the value of cos also keeps on decreasing. And as theta approaches 90 degree, the value of cos approaches 0. Then let us keep going. And as we keep going, we see that the graph actually just follows the sine graph. It is the same graph. It looks like it's a little shifted, but it just looks like it is following the sine graph. So let's see, cos theta value is approaching 180 degree, and as it approaches 180 degree, the value of cos becomes -1. See, now again, let us come back. So now I think you already started understanding. A little fast forward. So when we go like this, we see that cos also follows the same pattern. Now why did I show you all this? You might be thinking, some people might be thinking, why am I showing you all this? I will come to that. See, this is what we just saw. Okay, this is sine graph, and this is cos graph. This is exactly what we just saw now. This keeps on going, from minus infinity to infinity. It just keeps on going. Now, if you look at the sine, if you look at these two graphs, it looks like one graph is actually running behind the other graph. The blue is going, red is following. Or you can think the red is going and blue is following. It looks like that, right? Okay, let me bring you to another example now, where that is. Let us take two people for example, Uskita and Mushkan. Both these people decided to have a running race. So Uskita and Mushkan wanted to have a running race, and then we checked the speeds, and what we saw was the speeds were 5.4 meter per second and 5.3 meter per second. So what's the difference? 0.1 meter per second. So what we can infer, or what we can understand from this is, Uskita ran 0.1 meter per second faster than Mushkan. Likewise, now because running happens on land, and land measurement is taken in meters as a unit, so that is why we could say this difference is 0.1 meter per second. Now look at our graph. Here when we look at the graph, we see that there is no meter here, there is no land measurement here. But what is the difference? Look carefully. If you look carefully, we see that this value, the blue is sine approaches 180, angle 180, and sine value approaches 0 here at 180 degree, and the cos comes behind. Cos is following slowly, and it comes here. So what is the difference? The difference is this much, that is 180 degree minus 90 degree. 180 minus 90 is 90. Now that is why we get this formula, that is from there we get this formula: sine 90 minus theta is equal to cos theta. You have already studied this formula in the lower class, but did you ever think that this is what it meant? Sine 90 minus theta is cos theta, because both the graphs of sine and cos are exactly the same. Only thing, it is just a little shifted, and that shift is 90 degree. That sine of cos is a little lagging. We use the technical word is lagging. Okay, now cos is running a little slow behind sine, and that's how much slow? It is 90 degrees slow. Now suppose each person has a different way of looking at things. So if I think that, see, this actually goes from minus infinity to infinity. That means this graph actually never ends. You can go, it just starts at minus infinity, goes till infinity. Now, so I can either consider this blue as leading, going first, or I can consider this red as going first. If the red is going first, red is what goes, and blue is sine. So suppose I consider the red as the going red as going first. Suppose I consider that the red is leading, red is running, the running first in the race, or running the fastest. Then the red reaches 0 here at 90 degree. The red cos reaches 0, and the sine value reaches 0 here. So the red appears to reach faster. Yes, red appears faster here. If you go back, you see the red already has approached 0, and the sine only approaches 0 here. So what does that mean? That means, what is the difference here? Difference is again 90. 0 minus of minus 90. 0 minus of minus 90 is 0 plus 90. That means 90 degree. So again, it is 90 degree. What do we understand? So this is from where this formula comes. Cos of 90 minus theta is equal to sine theta. So I have shown you how these two formulas you have studied in the lower classes, but I don't think you have actually understood that time how why this actually happens. So this is a practical, or not practical, this is a visual demonstration of how these formulas actually work. You get. So guys, this will be it for today. I know it is a little bit long. It's almost half an hour, but I wanted to take this so that you would actually understand the beauty of trigonometry, and I hope I was able to deliver that to you. So from the next video onwards, we will go into little more depths. We will understand a little more few things. We will learn a little new things, and we'll go more into this chapter. Thank you all for listening. Do contact me if there is any doubts.